Hello and welcome to Cognito Key. Here we love to pull back the curtain on the amazing tech that's all around us. And today we're going to talk about a tiny, tiny device. It's probably in a dozen things you own right now, working away in secret. And it all starts with a question I bet you've thought about. Really, think about it. How does that work? You're sitting on your couch, you point this little plastic thing at the TV, press a button, and poof, the channel changes. Is it magic? Well, kind of feels like it, right? But the real answer is all about our gadgets being able to see, but not with eyes. The secret is this little guy, a true unsung hero of the electronics world. Seriously, it's one of the most important light sensors ever made, but you've probably never even noticed it. And this tiny champion is called a photodiode. So what in the world is a photodiode? Well, in the simplest terms, it's a special little device that can catch light, photons, and turn that light energy straight into electrical energy. It's like the electronic eye for our gadgets, translating what it sees into a language that circuits can actually understand. Okay, so how do you even make something that can see light? That's where things get really cool. It all comes down to its structure, which is basically, and I love this analogy, a high-tech semiconductor sandwich. Building one of these is a super precise process. So you start with your first slice of bread, which is a base of something called N-type silicon. Then you add another layer of N-type on top. Now, all you need to know about N-type and P-type is that they're just silicon that's been tweaked to have either too many or too few electrons. So on top of our N-type layers, we spread on some P-type material. And that spot where the P and the N materials meet, that is the most important part. That's the PN junction. Slap on some metal contacts so it can plug into a circuit, and your sandwich is ready. And this little sandwich is designed so cleverly. The top surface, where the light hits, has this special anti-reflection coating to make sure it sucks in every possible bit of light. The rest of it is protected with silicon dioxide. And here's the crazy part. This entire piece of engineering is only about 2.5 millimeters across. Tiny, right? All right, so we've built our little high-tech sandwich. Now for the main event. How does it actually work? How does it turn light into electricity? This is where the real magic, well, the science, happens. Remember that PN junction we talked about, the place where the two types of silicon meet? That is ground zero. Now, when the photodiode is just sitting in the dark, doing nothing, there's this little area right at the junction called the depletion region. You can just think of it as a no-fly zone for electricity. There are no free electrons floating around to carry a current. But then, bam, a photon of light, this tiny little packet of pure energy, comes flying in and smacks right into an atom in that no-fly zone. It gives its energy to an electron and basically kicks it free. And just like that, you've created a moving charge. As soon as that electron is knocked loose, the built-in electric field at the junction grabs it and pulls it away. And what is a flow of electrons? It's an electric current. And the logic here is just so elegant and simple. The brighter the light, the more photons are hitting the device, which means more electrons get knocked free, which means, you guessed it, a stronger current. More light equals more current. Simple as that. Okay, but no device is absolutely perfect, right? Even when a photodiode is in total darkness, a super, super tiny bit of current still manages to flow. It's called dark current. Think of it like a tiny leaky faucet. It's not a big deal most of the time, but for really sensitive gadgets, engineers definitely have to keep it in mind. So you might think that's the whole story, but this little photodiode has another trick up its sleeve. You see, it's not a one-trick pony. You can actually use it in two totally different ways or modes, just depending on how you hook it up. First up, you've got photo-conductive mode. This is the fast mode. You give it a little reverse voltage, and in return, it reacts to light changes incredibly quickly. The current you get is perfectly in line with how bright the light is. So this is your go-to for anything that needs speed. Then you have the other option, photo-voltaic mode. Here, you don't use any external voltage at all. Instead, it acts like a miniature solar panel, actually creating its own voltage from the light it sees. This one is perfect for situations where you don't have a lot of light or don't need super fast reactions. So, that's a lot of physics, right? But what's the bottom line? Why does any of this matter to you? Well, because this tiny piece of tech is literally the secret ingredient in so much of the stuff we can't live without. Let's go all the way back to the beginning. That TV remote? Yep, a photodiode is in your TV catching that invisible infrared signal. But that's just scratching the surface. They're the critical receivers in the fiber optic cables that make the internet work. They're in super fast computer circuits, barcode scanners at the grocery store. They're basically anywhere a machine needs to see light, whether it's light we can see or not. So let's wrap up the pros and cons real quick. The big wins for photodiodes: they are incredibly fast, and that pesky dark current is super low, so they're very precise. The one downside: they're not always the most sensitive kids on the block. Other things like LDRs can sometimes detect fainter light better. And this quote really says it all. When you think about the internet, you're really thinking about zillions of pulses of light traveling through fiber optic cables. Without the photodiode on the other end to catch those pulses and turn them back into data, well, our modern world would look very, very different. They are absolutely essential. Which kind of makes you wonder, right? We've got this amazing little light catcher down pat for what we need today, but what about tomorrow? As we get into things like quantum computing or next-generation medical scanners, what new secrets will these tiny sensors help us unlock? What's the next incredible thing they'll let us see? And that's the amazing story of the photodiode. I really hope you enjoyed diving into this with me. If you learned something cool, do me a favor and hit that like button, maybe share this with a friend who's also a bit of a tech nerd, and of course, subscribe to Cognito Keys so you don't miss our next explainer. Thanks so much for watching.